Welcome to LabMinutes.com in a lab video series on Cisco ACI 6.0. This is Mehta, your instructor for this video series. For a complete list of ACI videos, you can visit our website under Data Center section. There you can also sign up for our newsletters to receive the latest video updates. Up to this video, we have configured L3 out many times now, so we know that L3 out has a direct tie to a VRF, and the more VRF you have, the more L3 out configuration you potentially need. Even if you have multiple VRF share the same L3 out as a share service, which is something that we will cover in the future video, you lose the segmentation as the traffic will be merging as it leaves the L3 out. This is the problem that an ACI feature called Golf tries to solve, and you will see how that is done in this video. Let's take a quick look at our lab setup. We have one ACI spine, 2 leaves, and an APIC controller. The 2 ACI leaves are also acting as border leaves connected to our lab core switch 1, which is the path out to the internet. Switch 1 also provides an out-of-band management subnet VLAN 99, and this is how we are accessing our equipment in the lab, and the IP address is being shown in this diagram too. Connected to the 2 leaves are the LM-R1 lab router that we use as our test endpoint. There are 2 VRF on there, VRF A and B, so we call them endpoint A and B. We also have an ESXi server connected to our lab, and this is where our Windows 2019 domain controllers are sitting on. Logically, it is in the web EPG with the subnet 172.168.32.0/24. So our domain controller is right here, and the ACI leaves are the default gateway.1. Golf, or Giant Overlay Fabric, that's what it stands for, is a more scalable solution to provide external connections to ACI Fabric. Instead of you having one L3 out for each tenant VRF and having to run separate routing protocols as we did in the previous labs, Golf offers you a way to use a single connection to carry traffic for multiple VRFs, and this is accomplished by using MPBGP EVPN in the route advertisement. So this is how it works. Let me grab a pencil. You have a Golf router that is connected to ACI spine, and this is kind of break the traditional restriction, or I guess guidelines, that we have mentioned in the fundamental video where we said that the spine is not supposed to connect to anything else but leaf, but there's an exception, and this is one of the exceptions, is for Golf, or connect to the external layer 3 network. So the Golf router connects to the spine either via a direct connections or direct cable, or over a layer 3 network. Golf router and exchange and underlay routes with the spine via OSPF. And you see what those routes are. Once it learns the underlay routes, the Golf router will peers with the spine via MPBGP EVPN and exchange the overlay routes. So there will be a BGP session between the Golf router and ACI spine. Additional parameters such as the VRF name, bridge domain number, or VNI are sent from ACI to the Golf router via a protocol called offlex, and this is completely out of band, so the router can correctly apply the configuration for each of the segments. And again, you see what those configurations are and what they looks like exactly later on in this lab. Once the Golf router has all the reachability information, it will be able to forward the traffic correctly through the spine, obviously, to the leaf VTAP. And that's how the connectivity is established between external network via Golf to the ACI fabric. Let's take a look at this part of our lab topology. Our spine number 1 right here has a direct cable in connection to our Golf router. Over here, the cable is right there. We are using interface 33 on the spine and gig number 1 on the Golf router. They will run or have OSPF adjacency over this /30 network, and that will be over VLAN 4. So on the spine side, it will be a sub interface. For the VLAN 4, it might not be a .4, because you know how ACI can pick a different sub interface number from the actual VLAN number. But that same VLAN will be mapped to the Golf router gig number 1. And then on top of that, it will create eBGP peering between their loopbacks. So there's a loopback right here, 0.10, which will be advertised into OSPF. Same thing, the spine has a loopback of 0.101 that will be advertised into OSPF, and there will be a BGP that runs between that. We're going to be running offlex across that same link. So that's what we're going to be configuring. We'll talk about the logical configuration here as we go through the configuration itself.